Good morning all. This is Shalini Pathak from AITM Jaipur and my subject is Data Communication and Computer Networks, and today I will start Unit 3, that is Network Layer. Network Layer, the content in Network Layer which will I discuss is introduction, second is design issues, third is functions, fourth is routing algorithm. So, introduction of Network Layer. As you all know, it is a part of OSI layer and it comes in between transport layer and data link layer. Here's a diagram also given. So the first line is the network layer is concerned with getting packets from the source all the way to the destination. Means if the packet arrives from source and reaches to the destination, the procedure depends upon the network layer, or the procedure is done through the network layer. Second is to achieve its goal, the network layer must know about the topologies of the communication subnet and choose appropriate paths through it. Means there are so many topologies in the networking, such as ring topology, bus topology, hybrid topology. Which of the topology is being used, the network layer must know. Now, second is network layer design issues. First line is store and forward packet switching. What store and forward packet switching means? The two words store and second word is forward. I must clear out it. As the given diagram, first H1 is the host where process 1 is there. Second, process 2 is in H2. And in between H1 and H2, there is a carrier equipment. And in carrier equipment, there are various routers connected to each other. That is A, B, C, D, E. F is also a router, that is customer's equipment or customer router, which is, as you can say, the destination router, which is connected through a LAN. So if the packet arrives from H1, it will decide the path and reaches to H2. So here the packet is stored here until it is fully arrived, so that checksum can be verified. Then it is forwarded to the next until it reaches to the destination. This mechanism is called as store and forward packet switching. Second is services provided to the transport layer. It means services should be independent to the router technology. Network address made available to the router should use a uniform numbering plan. C is implementation of connectionless services. It means the connection services is connectionless, that is unreliable. Error control, flow control are done themselves. So we can say there is no advanced setup is needed. In this, packets are frequently called datagram. D, implementation of connection-oriented services. It means that services is reliable. Main factor is quality of services. In this, path from source to destination router must be established before the packet can be sent. This is called virtual circuit. Now, functions of network layer. There are 4 functions. First is addressing, second is packetizing, third is fragmentation, fourth is routing. Now, addressing means it is necessary to identify each devices on the internet uniquely. Packetizing means the network layer encapsulates the packet received from the upper layer protocol and makes the new packet. How it is done? It is done by using an IP address. That is, you can say this is done by adding a header to the data that contains the logical service, that contains, you can say, a logical source and destination address of the packet information. So in this, basic main point is your internet protocol, which you can use to deliver a packet to the destination. Third is fragmentation. The fragmentation means Suppose a router is bounded with a capacity and it is not be able to accept the packet beyond its capacity. So the datagram needs to be fragmented to the smaller unit before passing to the data link layer. Fourth is routing, means before sending to the, or you can say after starting of the packet delivery, the route is being decided through this routing. So these are the 4 functions which is performed by network layer. Now routing algorithm. The process of forwarding the packet in a network so that it reaches to the intended destination is called routing. Basically, routing is the route which you will decide to reach the destination. As in the given diagram, there are 5 routers connected to each other. Suppose first packet or one packet arrives from the router B and reaches to the router C. So B will decide that it will move through BDE or BEC. This deciding of the route will be done through different algorithms. Lots of algorithms are there to decide the shortest path. As I'm using the word shortest, why we are using the shortest path or why we are dependent on the shortest path? So that the time period can be maintained, or you can say so that in minimum time we can reach to the destination. Okay, now there are, as I've said, there are lots of algorithms. Just for example, Dijkstra's algorithm, Bellman-Ford algorithm, and Ford-Fulkerson algorithm, which we will discuss in next lecture, or we can say later on. Now, features of routing algorithm. What are the features? First is correctness. Correctness means routing should be done correctly so that packet can reach a correct destination. Second is simplicity. Routing should be done in simple manner so that the path is as low as possible. Robustness. Third point, the ability to withstand the system over a year. Means at any condition, it should be robust. Fourth, stability. Routing algorithms should be stable under all circumstances. Now, last point is optimality. Basically, optimal should be in terms of path throughput and minimizing the packet delay so that in limited period of time, a packet can reach to the destination. Now, types of algorithm. There are basically 2 types, static that can be called as non-adaptive and dynamic that can be called as adaptive. Static, the word it clears that it cannot be changed in between. Means if you have started to deliver a packet or to send a packet to the destination via one path, so if there is a breakage in the network, that means there is a loss of the connection. You cannot choose another path. Dynamic means you can choose any of the path to reach the destination. Now, static further be divided into 3 parts. That is shortest path. Second is flooding. Third is flow-based. Shortest path means you have to select a path that should be in comparison to other paths should be shortest one. Second, flooding means all the information should be distributed to other routers. Next one is flow-based. The routing should be flow-based. What are the costing should be in basis of the flow. Third, next point is dynamic. Dynamic is further decided into distance vector and link state. Then the term distance vector. Distance vector means now you can say that in modern computer network we use normally this dynamic. Means you just create a router table where you can carry on different of the information of other routers and then the procedure starts. Similarly, exchange of the information is being done. Now, what we have completed or what we have covered, the basic thing, I'm just concluding. First, is an introduction, how it is done, what is the basic working, where it is present in OSI layer. Second, what are the functions, why we are using this network layer. Third, now routing algorithm, different parts. So further in next lecture, we will carry forward that what different algorithms we will use to cover this shortest path. Thank you very much.